Hi, welcome back from half term. As you can see, I am in the room, but I'm not at the front. I've been signed off by the doctor for 3 weeks, so I will not be in college. However, I will be here on your screen teaching you today's lesson, and then the cover supervisor or teacher or whoever you've got there, I'm sure will help you out if you need help. Also for help, if you haven't got a specialist maths teacher there, which I'm not sure if you will, I shall be available on Wednesday afternoon on Teams between 1 and 3. If you've got any questions for me between 1 and 3 on Wednesday, I would love to see you. Even you, Daniel. So hopefully some of you will come on Wednesday and ask me some questions. Right, let's get on with some work. Oh, I must say, better pause here because it's not really my lesson, is it? This is my cousin Kat's lesson, and she is here helping me being off, so I'm afraid you're not going to get her either. So let's see if she's available and she can start some mechanics with you. Hello there, Kat here. I'm looking after Kathy, so still like her, won't be in college for the next 3 weeks. Thought I'd put my hat on today because it's only just past Halloween and I've had a lot of fun with that. Hope you did too. Trick-or-treating every year. Not knocking on too many doors this year, but I was hovering around with my black cat up and down the street. Anyway, let's get some maths done. Right, here's a starter question for you on the whiteboard. You can do it on the small ones, probably better than the big ones. It says a ball is projected vertically upwards and hits the ground at the point of projection 8 seconds later. So you know T. Find the speed of projection and the greatest height reached by the ball. Remember here, you know that acceleration is the gravity because it's an up and down movement. So that's 9.8. You can take it as that. So you know T, you know the thing's 9.8. Remember at the top of the greatest height, the velocity is 0. So that might help you. So it's really asking you to find the speed of projections. That's the starting speed. And the greatest height, that's the distance that the ball will reach. Right, there's a little song while you're having a go at this. I think your teacher can press play on it to get it to work. I'll press play on it and see how long it lasts. So play the song and try that question.
B squared is U squared plus 2AX. 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 X equals half U plus B times B. 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 Equals U plus 8. X equals UT plus half AT squared. X equals UT plus half AT
Wow, hopefully you had that song and don't play any of these others that might be coming up next. Let's move on. So here's the answer. I think you have to probably press move to get to the answer. But there's the answer. So the ball, when the ball hits the ground, its displacement is 0. We needed to think of that as well. Taking upwards as positive, so you had the distance as 0, the acceleration was minus 9.8, t was 8, and the initial speed was what you were after. Using s equals ut plus half at squared, you've got that one. And then the projection of the speed, then that's its velocity, its initial velocity is that. At the greatest height, the speed of the ball is 0. We wanted to find s this time, so we used v squared is u squared plus 2as, and then you got the s there. I'd say hands up, see how many got success, and then the teacher can see. Okay, so that's a recap of last lesson. Let's now look to this lesson. Hope the video worked for you. Right, Kinematics 4. We should have the sheet that you took, where you took that bundle of sheets that says Kinematics 4. So look in your folders. You've already been given this lesson handout. If you were absent on that time or you've eaten it over the half term, then there may be a few spares in the white shelves next to the teacher's desk in the box called FM1. Please don't rustle in any of the other boxes because everything's in order. Go in the box that says FM1 and see if you can see towards the top Kinematics lesson 4 worksheet if you haven't got one, or the teacher might have a quick look and see if there's a packet in there. In that packet there'll be some worksheets that will come in helpful towards the middle of this lesson. Right, okay, let's get on. So today is lesson 4, the last of these kinematics lessons. We're going to practice using SUVAT again. We've got to be able to solve multi-stage SUVAT problems. To understand SUVAT can only be used in acceleration if acceleration is constant, and to practice maybe an example. Right, so here we've got specific SUVAT equations must only apply with constant, acceleration remains constant, and we must create new SUVAT equations each time the acceleration changes. So I've got a little story here. We've got a cyclist starting at a speed of 2 miles per meter, whatever it is, per second. Reaches the top of the hill in 5 seconds. He then continues on the flat, covering 13 meters in 1 second. Assuming acceleration assuming that he accelerates uniformly for the whole 6 seconds, calculate the constant acceleration, the distance travelled. And B, find the speed at the end of the 6 second. Right, a lot going on there. So we'll split this into 2 here. So in the first 5 seconds, what the devil is going on? Right. Let's move. I've got too many things on this table. Right, so the first 5 seconds, we're told that the cyclist starts at a speed of 2. So U is 2. And reaches the top of the hill in 5 seconds. So we know our T is 5. Velocity at the end of the 5 seconds, we are unaware. Acceleration, let's just call that A because we don't know that either. And S, we don't know what that is. Let's make that up as a letter. So we've only got 2 things that we know there, so that's not much use. That's not going to help us too much. So in the first 6 seconds. So let's include that 1 second now. So u still is 2 because you started off at speed of 2. Velocity we still don't know, but we might want to know. Oops. So I'll put question mark. Let's just call acceleration is still a, because it's constant acceleration throughout. And s will be the distance it did to get up the hill plus the 13 meters is covered on the flat. The time it takes him to do all that is 6. So now using equation relates to u, a, s and t is that one. S equals u plus half at squared. So if we use that for both of these, we'll get for 5 seconds, we'll get x equals, this is for this one, s equals 2 times 5, which is 10, plus a half a times t. So half a times t will be 2.5 a, won't it? If we think of the whole 6 seconds, the distance we travel is x plus 13 equals ut, so that'll be 2 times 6, which is 12, plus half at squared, so that'll be a half, oh sorry, I should have done t squared, shouldn't we? Ooh, a half of, made a mess there, didn't we? Half of t squared. T squared is 25, so back to the other one because I couldn't see it with mine in the way. T squared would be 25, so a half of that would be 12.5. Right, I'll do this one right. So t squared is 36, so half of 36 is 18. So we've got 18a there. Right, you can see what's happening here now. We've got 2 equations, 2 unknowns, it's simultaneous equations. So let's try and solve them. So let me write those out again. If I write them out as x minus, rearranging them a bit, 12.5a equals 10. Switching the other one around, we get x minus 18a equals, in fact, minus 1. Putting those in your calculator, equations mode. Picking simultaneous, 2 unknowns. Put them in 1, minus 12.5 and 10. So it wants them in that form because the calculator asks them for in a, x plus b, y equals c or something. Put them in that form. So I've put them in that form. So all you have to read off now is 1, minus 12.5 and 10. 1, minus 18 and minus 1, and if you press the buttons, whizzy whizzy whiz, and out comes A as, somebody can do that. Get your friend, mine's a little bit older than yours, not in colour. So it was, remember, menu, equations, simultaneous, 2 unknowns, put in the business, and A, it says, is 2, and x, in fact, is 35. Hope you got those two. Right, what oriented? Oh, we've done the question, haven't we? We've answered the question without me knowing there. We've answered the question, was calculate the constant acceleration, that's the A, and the distance travelled. So we should put 35 meters, and acceleration is meters per second to the minus 2. Right, part B asks us to find the speed at the end of the 6th second. So we're trying to find V, aren't we? Right, okay, so V equals U plus AT. So V equals initial starting speed's 2 plus, now we know A now, AT, so 2 times 6, that comes out at 14. So the speed at the end of the 6 second is actually 14 meters per second. It's -1 meters per second, isn't it? Lovely. Well, that was okay. On the whiteboard, then, you try this similar one. 3 cameras are positioned on a straight road. The distance between the first and the second camera is 50 meters, and the distance from the second to the third camera is 30 meters. A car passes the first camera with the speed of u and immediately starts braking. It passes the second camera 3.1 seconds later, and then the third camera 2.3 seconds later. After that, assuming that the deceleration remains constant, find the value of mu and constant acceleration. So first look for a suvat from the first to the second camera, then look for a suvat from the first to the third camera, and then solve the simultaneous equations. You could do it slightly different if you wanted. Somebody's thinking that. See if you get the same answers. I'll let the teacher now pause and give you a bit of time to have a look at that. Right, okay, might have unpaused now. Here comes the answers. Between the first and second camera, those things you know. Between the first and the third camera, those things you know. 2 simultaneous equations get created from those, like using S equals ut plus half at squared. Solving them. Those are 2 simultaneous equations highlighted there. And that gives you u is 18 and your acceleration, because it's deceleration, it's minus 1.14. Hope that you managed to get those, or some of you did, and some of you just thinking you were halfway there. Let's see what's next. Another multi-stage problem. So remember, we have to make 2 different suvats when the acceleration changes. The acceleration is constant, but it's not constant over the 2 bits we split it into, if that makes sense. So the acceleration changes. It still stays constant, but it changes. So here we've got a car starts from rest and accelerates at a constant rate of 2.7. So let's fill in the things from that straight away. So from that, starts from rest, so we know that u will be 0 and constant acceleration of 2.7 for 6 seconds. Then it changes to a higher gear and accelerates for 10 seconds, reaching a speed of 28.2. Whizzing along. So what we can do from that is we can say that the final speed on stage 2 is 28.2 seconds. And that's when it's accelerated for 10 seconds. Right. Find the velocity after 6 seconds and the acceleration for the second stage of motion. Oh. Right, do we know anything else? No, we don't, do we? Right, let's have a look. Well, we've got 3 things here on stage 1, so we can find things out when we've got 3 things. So we're going to go find the velocity after 6 seconds. Oh, that's this bit here, isn't it? This is 6 seconds. So velocity v equals u plus at. So v, which is what we're after, question mark here. I'm going to find what it is. Get off. Use a different colour pen. Yeah, what's going on? So v equals u plus at, 2.7 times 6. So that comes out at, on your calculator, 28 point. No, it doesn't. It comes out at, that's rubbish. Who said that? Daniel. Naughty boy. That comes out at 16.2 meters per second to -1. Okay, so now, having got that, let's find the acceleration of the second stage of motion. So at the start of the second stage of motion, that's after the 6 seconds, u will be 16.2 meters per second -1. Put that in as that now, that's that in the question mark, equals 16.2. Right. So now, find acceleration. We can still use this, because that's what we know. So now, v equals u plus at, and A is what we're after, isn't it? And if you miss those around, you will get A equals 1.2 meters per second to -2. All done. So that's what we're after. Okay, here's another one on the whiteboard for you. How lucky can you be? Another multi-stage problem. So many two-stage problems involve vertical motion. You need to be careful about the direction of velocity and acceleration. So a toy rocket with an engine starts from rest at ground level and moves vertically upwards with an acceleration of 3.6. After 3 seconds, the engine is turned off and the rocket moves freely under gravity. So let's visualize that. So here is your rocket. The engine now turns off. Now when the engine turns off, the rocket will still go up a little bit before it then starts to plummet back to Earth. So there's a stage when the rocket's going, the acceleration is 3.6, and when the engine cuts off, the acceleration now, because it's against the rocket going up, is -9.8. So if we can picture that on a velocity time graph, what we'd have here, that's what this triangle is on this side, we have initially the rocket's going up until it hits this point here. This is where the engine cuts off. Now the acceleration's -9.8. So the rocket then, this is when it starts still going up a little bit. A very great diagram, but it's still going up a little bit until it hits its greatest height. Now when it hits its greatest height, we know that velocity is 0. That's when the speed 0, it's that millisecond, and then speed's going down, isn't it? Speed's negative. Or velocity is negative until it hits the ground. Again, when the velocity will be made to be 0 when it hits the ground. or maybe it won't be, the velocity will be 0 in the end, but anyway. Right, so what we have to do is find the speed of the rocket when the engine stops and the displacement when the engine stops. So that's going to be one stage, because remember we model this in 2 stages. One, we have to model it differently when the acceleration changes. So we'll start off modeling when acceleration is 3.6. So put that in. We know its initial velocity, because it started from rest, is going to be 0. Final velocity is what we're asked to find for part A. So we need to know that. And the time it takes that's 3 seconds before it cuts off. So the equation that we want here after V, we know these three, is V equals U plus AT. So 0 plus AT, 3 times 3.6. And that comes out to be on your machines. You try it, 10.8. So you can put that in. I'll change colour, then you know what I've been up to. Green. What's that song? I've forgotten it now. Anyway, the displacement when the engine stops. So we're after this now. When the engine stops. So that's when it cuts off. So that's when our acceleration changes. So what we want here, then we need a formula. It doesn't matter which, does it? Because we've got all of these things, but we'll choose this one. S equals ut plus half at squared. Right, so S equals 0 times something is going to be 0 plus a half of 3.6 times t squared 9, and that one comes out to be 16.2. So we've answered A and B. C, the greatest height reached by the rocket. So we're modelling all of stage 2, all of when it goes, still going up in the air slightly after the engine's conked out, to down. All of this slope here is stage 2 on the diagram. That's stage 2. So S, I don't know the distance. Let's change my colour again, black. U, that's initial speed when it cuts off. We know that's the final speed of this. This is 10.8. When it actually, if we say when, because here we're after when greatest height. So let's make the velocity here the greatest height 0 at greatest height. So it stops and that's the very top, so it drops down. Acceleration we know is minus 9.8. And we're asked to find the greatest height, so after the S. So working that out, we want a formula with S, U, V and A in it. That's V squared is U squared plus 2AS. So we've got V squared 0 equals U squared. I'll work that out for me. Yeah, there's that on my paper. No, let's just leave it as 10.8 squared plus 2AS. So that becomes minus 2AS. So that'll be 2 times, the unknown that we want, times a, so 2 times a, so that's going to be minus 19.65 s. And then if you rearrange that, that's a bit bad, isn't it? 19.65, that says s, I'm squashing it on. And when you work that, rearrange it, you finally get your s to be 5.95. So that's basically that, what that would be there. As the acceleration, as the engine cut out, it still did another 5 meters in the air, and then it dropped. So the total height, I can't write it on because I'm in the way, but I will make myself smaller when I direct it. The total height will be that plus the height it made here. So the height it made here is 16. So I'm going to put an asterisk on that and put it up here. So total height or greatest height will equal the 16.2 plus the 5.95 it did when the engine cut out. So that all comes to 22.15 meters. So that's part C. We've still got D to do. I'll have to turn over for D, but we're after the total time the rocket spends in the air. We know it's had 3 seconds before the engine cuts out. We need to work out what this is here. How many colours I've got? I need to work, oops, come here. I need to work out that one. And then I need to work out this, so the time it takes to do this, to each hits out, and then the time it to hits the ground. So we've got a lot on that. Let's have a bit of more space. Okay, finding the total time it takes. Right, we're going to model all of stage 2 now, not just as it hits to the top. We're taking stage 2 when our acceleration is minus 9.8. That we know. But the start of stage 2, now that's not the total height it's reached, that's the height when the engine cut out. So it got up to, before, well, as soon as the engine cut out, it got up to 16.2. It went up a little bit and then it went all the way down. Now, as we're trying to find here, the total time sits at the air. We're trying to find when it's at the bottom, aren't we? So when it's at the ground. So when we try to find it, at the starting point on the ground. So the ground is 16.2 above the starting point for the second stage. So that means we need this to be negative. U, when the engine cuts out, remember, was 10.8. And velocity, well, we don't know that. And time, we don't know that either. But we're after time, aren't we? So that's the one we're after. Let's put a question mark on that. So we've got S, we've got U, we've got A, and we want T. So that's this formula here. So S minus 16.2 equals 10.8 T plus a half of that. Do I know what that is? Minus 4.9 T squared. So here we've got a bit of a quadratic equation going on. So we take all those over, we'd have 4.9 T squared minus 10.8 T, and then we've got on there minus 16.2 0.2 equals 0. So if we stick that in the calculator, so equations mode again, polynomial, degree 2, and then solve that one. So stick it in as 9.8 minus 10.8 minus 16.2, and the calculator comes up with t is 2 values. That's what you get these. We've got minus 1. Oh, Bubble! Bubble! Come here, Bubble. Right, so t equals, have you done the calculator? 1.02, and the other number we get is 3.23. So obviously that's a bit of nonsense. This is what time it takes, and so this is the time of the second stage, remember. So the total time will be the time of the first stage, which we know was 3, plus the time of the second stage, which is 3.23, which comes to a total time of 6.23 seconds. And bingo, we are done. Right, here's one for you, I think. The car is moving along a straight horizontal road with a constant acceleration. There are 3 points A, B and C in that order. On the road where A to B is 22 metres, B to C is 104 metres, the car takes 2 seconds to travel from A to B and 4 seconds to travel from B to C. Sort of displayed in that diagram there, isn't it? Find the acceleration of the car. So if you split it into two things, well, and find the speed of the car at the instant it passes A. So it's going with constant acceleration. I'll let you have a go. And we have to find the two simultaneous equations and solve them. So we pause in this now, please, while you have a little go. Okay, unpause, you've had a go. Hopefully you got those set scenarios for A to B, those scenarios for A to C. Then you built yourself up, two equations there. 22 equals 2u plus a 2a, and 126 equals 6u plus 18a, and then solve them simultaneously, you get 5 for a and 6 for u. All right. Is there any more, you wonder? Well, no. You've got a worksheet now. You should have that with you. You should have had this sheet as well with you, but should have said right at the beginning, and I might alter it, that we should have had these sheets with you, and so we hopefully had these worksheets with you, and you should have the question sheet. Well, actually you don't have this question sheet. I'm lying, how dare I. In the back in the box, which is labelled further maths 1, which it shouldn't be, FM1, where your stuff is, this worksheet is there with Kinematics 4, any spares I had for it, So there's a packet in that box which is labelled FM1 on the left hand side on the white shelves. If someone could go to the box, or a teacher could go to the box and have a look in that box for might be a Kinematics 4 sheet on the top, and the worksheet you should be doing. I've got a copy of it to show you what it looks like. I'll pause this and go and run and get one so you know. So here it is. This is the worksheet we should be having. That's in the box. Someone could get those out, hand them out. You can start having a go at those questions. There is only those questions on the sheet. I've deleted the others. So stop the video, have a go at those questions, and then last few minutes you can try the exam question, but I'd like you to have a go at these questions first. So enough from me for now. Please pause, and then in the last 8 minutes or so of the lesson you'll perhaps put up this exam question which is coming now, and let those who want to have a go at it have a go at it. And those who are still just enjoying the sheet can carry on enjoying the sheet. So bye bye for a minute. Please pause. Okay, you've unpaused. It's last 8 minutes perhaps. If you think it's worth it, then here was the well, it said you've got an exercise there. Well, we're not bothering with that. Here is the exam question. The last 10 minutes. I've said 8 anyway. If it's the last 10 minutes of the lesson, you'll be maybe having a go at this question, or I'm not bothered if you want to just carry on with the worksheet, that's fine. But pause this thing again if you're having a go at the work, having a go at the exam question. They can just flick my answers at the end, very end of the lesson. Or maybe you've not got time for this. We'll find out. Okay. So here we have the answer. You can do this 2 ways actually. So initial velocity, we could have done that by, that's finding u, isn't it? We model it as going up. When it hits the 23 meters, velocity is 0. S, because it's 23 meters up, but it started at 2.5 above the ground. So S is actually 23 minus 1.2. And because it's going up, acceleration is against it, so that's minus 9.8. Stick that in the formula, gives you U as 20.7. Then using the motion downwards only, this is like downwards bit, so I'll model this as positive going down. So U is 0, A is 9.8, distance it's got to hitch to reach the ground is 23. Do all that. And then part C, we have to hear the total time the ball is in the air. This is the bit that we could do it in 2 ways. If we're taking T as positive and going down, we've got those things. So just using that formula, time can work out to be 4.28. We could have done part C using stages, stage up and stage down, and added them together. In stage 1, the ball going up, so those things, the time works out at that. Stage 2, we've got the ball going down, modelling it as that, so modelling down, velocity is positive downhill, you get the 2.16, add them together, 4.28. So either way, if you did those, great. If you didn't get a chance to do them, this will probably, well, it will be hanging about on streams on your page, so you have got the choice to relook at this video at some point. Okay, anyway, bye from me for a week. Kathy should be able to help you on Teams on Wednesday afternoon if you are getting stuck with these. She has a bit of idea of mechanics, but trust her. But she does sort of know what's going on, but she's not that great at mechanics. So, but she can help you with these. She's not that bad. So she can help you on Wednesday afternoon if you're getting stuck. All right, so bye from me for a week. See you soon.